The moment was quiet. There was no global headline, no emergency broadcast, and no official word from any space agency. But buried deep inside the silent corridors of one of China's most powerful sky monitoring networks, something had been logged. Something that rewrote the way we look at comets, and possibly even the concept of what an interstellar visitor could be. December 21st had started like any other day. The Chinese Deep Sky Array near Mohe had been running continuous long-range scans of 3I Atlas as part of a joint surveillance effort launched weeks earlier after the object survived its solar perihelion. That event alone had caught everyone off guard. Scientists from around the world watched as this cold, ancient wanderer from outside our solar system passed dangerously close to the Sun, and instead of breaking apart or burning out like most cometary bodies, it did the exact opposite. It glowed, intensified, shifted, survived. And then something even stranger happened. It grew stronger, its tail reversed, then fractured, then realigned in a configuration that no comet should be able to maintain. The magnetic resonance around it began distorting nearby readings, and when Earth-based observatories tried to chart its return trajectory, they noticed micro-adjustments, small, controlled course shifts that mimicked intelligent propulsion. Still, NASA stayed silent. The ESA's daily logs grew shorter, and now China, one of the only countries still observing the object in full spectral coverage, had gone quiet. Not out of failure, not because of shutdowns, but because something had changed in their tone. What was found wasn't just a thermal anomaly or a strange rotation pattern. It wasn't a tail flare or a dust cloud anomaly. It was something inside the object, something dense, something structured, and something that didn't appear to be of natural origin. Let's break this down slowly, one layer at a time, because the further we go into this timeline, the more the silence feels deliberate. Normally, when an international body like China's CNSA makes a discovery of this magnitude, a controlled academic report follows. Even during geopolitical tensions, science has historically transcended national boundaries, especially when it comes to rare celestial events. But this time, nothing. No conference announcement, no research note, no confirmation or denial, no chatter from observatory staff, just a growing silence. Except that silence isn't empty, it's filled with patterns. And for those listening closely, those patterns look more like red flags. On the morning of December 21st, the Chinese Space Science Center quietly released a burst of high-resolution images taken by their Solar Observatory Array. At first glance, the data looked routine, just another update in the stream of comet tracking. But buried within the release was one image that did not match anything from other agencies. It captured a narrow, bright ring around the nucleus of 3I Atlas. Not a dust shell, not a debris cloud, but something circular, structured, and luminous, coherently wrapping around the core. Within hours, astrophysicists across China were scrambling to rerun the filters, recheck the spectral alignment, and verify the data compression, and when they did, the results were clear. The ring wasn't noise, it wasn't distortion, it was real, and that was the moment when the story changed. Because if that ring is real, if it truly surrounds an object that just passed within range of the Earth's most powerful observatories, then something else is happening here. Something structured, something possibly engineered. And yet, as of this recording, NASA has made no statement, no press release, no update, no denial. The official narrative remains silent, which means we are left to confront the implications ourselves. Over the next 22 chapters, we're going to walk through everything we know about this image, the context behind it, the timing, the patterns, and most importantly, the question everyone is now whispering but no one dares say out loud. Is this still a comet, or are we watching something deliberately built? Because the ring was only the beginning. It began quietly, almost without notice. At 03:42 Beijing time, on the morning of December 21st, a routine batch of observational data was uploaded to a lightly trafficked server operated by China's National Space Science Center. The file was labeled as part of a continuous solar proximity tracking program, one of many automated releases that typically pass under the radar of the global science community. Most people never see these logs, raw data, sensor timestamps, compression codes. But this time, something was different. Buried in the third layer of the compressed feed was an image. High contrast, low noise, unusually well centered. The subject was familiar. 3I Atlas, the interstellar object that had stunned astronomers for weeks with its strange behavior near the Sun. The object had already survived perihelion without fragmentation. It had defied predictions of disintegration. It had emitted structured jets and showed anomalies in tail direction and intensity. But nothing looked like this. The image was crisp, too crisp. It showed what appeared to be a coherent, tight nucleus enveloped by a faint but geometrically circular glow. Not a fuzzy coma, not the expected tail, not a chaotic snowball of gas and debris. Instead, the object appeared wrapped, encased even, by a ring of concentrated light. Faint, but visible, symmetrical, controlled. Within hours, the image spread beyond the firewalls. First, it was picked up by a small group of international amateur astronomers who passed satellite feeds and foreign observatory outputs. One of them, a retired physics professor based in Vancouver, flagged the image on a Reddit thread with a simple caption, "This can't be real, right?" That post, buried at first, began to circulate, slowly, then with increasing speed. By 06 Ruwa UTC, several astrophotography forums were analysing the image frame by frame. Arguments broke out. Some claimed artifact. Others insisted it was just internal reflection, a glitch in processing. But then a curious thing happened. Analysts who cross-checked the image against the raw spectrum saw no compression spikes, no telltale signs of pixel interpolation. The ring wasn't a byproduct. It was in the light curve itself, a consistent concentric anomaly centered exactly on the coordinates of 3I Atlas. And then the silence set in. No confirmation from Chinese state observatories, no follow-up releases, no secondary angles. The image was there, and then nothing. The official websites began slowing down, logs were pulled, the full directory vanished behind password protection. By the time astronomers in Europe were waking up, the only remaining copy of the original image was a screenshot circulating on a Telegram group for deep sky anomaly watchers. But it was too late to contain. Within the scientific community, conversation shifted tone. If the ring was real, it had to be explained. Was it an ice halo? A diffraction pattern? Plasma sheath? Nothing fit. Comets didn't form rings, not like this, not in this shape, not with this level of angular symmetry, and yet it was there. Which is why this moment matters, because in a single frame captured before dawn in one corner of the Earth, something quiet unravelled. The veil lifted, even if just for a second. Not through a government agency, not through billion-dollar optics, but through a fragment of light that somehow made its way into the open before the doors slammed shut again. From that moment forward, the question changed. It was no longer, what is 3I Atlas doing? It became, what are we being kept from seeing? And this image, this ring, became the first piece of that puzzle. Once the initial image slipped into the public domain, attention turned toward the raw observational data behind it. China's space agencies rarely publish full telemetry logs in real time, but in this case, the original release, before it was locked, contained more than just a single visual. Tucked into the margins of the download package were metadata tags, exposure timestamps, and spectral alignment markers that, when reviewed carefully, told a more complicated story. At first it looked routine, a 32-second exposure, wideband optical lens array, filtration through a solar scatter suppressor, all standard equipment from the Chinese Langfang Optical Solar Array, a lesser-known ground-based observatory that specializes in long-distance spectral modeling. But as image analysts passed the exposure layers, something immediately stood out. The image had been passed through 5 separate digital filters before being released. Not 1 or 2, 5. The question was why? Every filter applied to space data is designed to clean noise, reduce atmospheric distortion, or isolate a specific frequency. But the 5th filter, marked only by an internal Chinese tag known as Zhen mode in the compression string, was unfamiliar to Western scientists. Some guessed it was an edge detection overlay. Others believed it was a depth-weighted smoothing algorithm. But when the filtered bands were reverse-engineered using standard processing software, the same pattern re-emerged. The ring wasn't a side effect of processing. It was present in every filtered version, even the earliest one, even the unstacked exposures. This wasn't a digital illusion. The structure was embedded in the raw light signature, visible even when the image was downgraded to grayscale. It remained locked to the object's centroid and maintained proportional brightness decay regardless of what spectrum was analysed. And then, the real anomaly surfaced. In a small sideband log, an automatic data register meant only for internal diagnostics, there was a note, a single line, time-stamped less than 4 minutes before the image was processed. It read, 3IA marked for level 4 filtration, ring geometry pattern recognized. That designation, level 4, isn't standard. It doesn't appear in any of the Chinese National Astronomical Centre's public documentation. But within hours of that tag being activated, every access point to the observatory's cloud pipeline was rerouted through an internal Chinese firewall. Outside logins were suspended, and the public archive where the image had first appeared went offline. What triggered that filtration? Why did a simple comet image require a level of pre-processing higher than what's used for solar flare hazard mapping or planetary defense coordination? Speculation exploded behind the scenes. Some believed the object had exhibited a coherent EM field, something bright enough to be interpreted as reflective but too structured to be thermal. Others argued that the ring was evidence of a haloing plasma boundary, perhaps the result of ionized particles behaving in a controlled fashion, forming a sheath or containment layer. But those were just guesses. The truth is simpler and more uncomfortable. The ring was not chaotic. It was geometrically centered. It did not fluctuate between exposures. It did not smear or wobble with atmospheric distortion. It held. And when scientists checked the angular resolution from the original file, it became even more troubling. The arc of the ring measured just over 145 degrees, too uniform to be outgassing, too perfect to be thermal blooming, and too symmetrical to be a dust halo. Comets do not emit clean partial rings that remain stable across frames. They produce clouds, jets, spikes, and flares, not bands. What China's instruments captured was not an explosion, it was a structure, and someone behind those filters recognized it. They marked it, they tagged it, and they locked it. So now the question is no longer whether something was seen. It's why someone tried to keep it hidden before the world could ask what it meant. It started as a faint outline, just a contour, barely visible to the naked eye, especially for those trained to expect chaotic comet shapes, irregular blobs, crumbling fragments, ice ridges. But in the enhanced layers of the Chinese observatory image, once you adjusted for light intensity and stripped away solar scatter, the silhouette of 3I Atlas began to tell a different story. The object wasn't round. It wasn't even irregular in the way natural comets typically are. Instead, it was tight, compact, smooth. From several angles, reconstructed using simultaneous observation timestamps and motion vectors, the core of 3I Atlas appeared almost fusiform, a long and narrow structure with a bulge in the middle tapering at both ends. A shape more commonly found in engineered spacecraft, not in tumbling space rocks. That alone would be strange. But it was the way light played across the surface that triggered a wave of private concern within the astrophysics community, because the reflections weren't diffuse. They were specular, meaning the light bounced back in a focused direction, like sunlight glinting off metal, not scattering off dust. This was not a rough or porous surface. It was smooth, uniform, possibly reflective on a microscopic level, and across 3 independent observation stations, Langfang in China, Siding Spring in Australia, and Mount Lemmon in Arizona, the reflectance pattern matched. 3 observatories, different hemispheres, same structure, same shine. But here's where it breaks the model. Natural comets rotate unevenly. Their surface texture is random. As they spin, their brightness flickers irregularly. Peaks and valleys appear depending on which face is exposed to sunlight at any moment. It's a slow dance of thermal absorption and dusty chaos. 3I Atlas did none of that. Its brightness curve was almost flat. Flat, not because it wasn't rotating, but because the reflected light followed a rhythm that didn't match random spin. Instead, it suggested that the surface had a controlled or consistent geometry, one that didn't change much even as it turned. A body shaped deliberately to reduce light variance. One astrophysicist reviewing the exposure sequence described the structure in his notes as too clean to be incidental, not tumbling, not fragmenting. This is not a comet, this is a form, not a rock, not a dust cloud, a form. And then came the outline. When image analysts overlaid isophotes, contours of equal brightness, they noticed that the brightest concentration wasn't in the middle, where you'd expect the densest ice to sublimate. Instead, it formed a ring around the core, the same ring from earlier, but now clearly intersecting with the object's axis of symmetry. It looked like a band, not a glow, not a jet, a ring around the waist of something. Longer, possibly cylindrical, maybe even aerodynamic. Aerodynamics shouldn't matter in space. There's no atmosphere to push against. But if an object is engineered to pass close to stars, close enough to experience particle friction, solar wind, magnetism, then shape starts to matter again. You don't design a cylinder by accident. You don't generate symmetric light bands by chance. And you certainly don't maintain structural cohesion after surviving a solar approach unless your shape has purpose. This is what terrified the scientists who saw it. Not because they thought it was alien, but because they knew this shape shouldn't exist naturally. Not in this configuration, not in this symmetry, not under this level of radiation stress. It is a form that implies engineering. A silhouette that whispers, this wasn't made by ice and dust alone. And yet, no official agency has acknowledged its outline. Because once you admit the shape is wrong, you have to admit everything else might be too. For weeks, NASA had been a constant voice in the background of the 3I Atlas story, publishing updates, correcting orbital models, confirming outgassing events, and reassuring the public that everything being observed fit within the bounds of cometary physics. Their press releases were calm, clinical, consistent. Until December 21st. That day, everything changed. As news of the Chinese image began to trickle across private scientific networks, those watching NASA's data feeds noticed something unusual. The updates stopped. No new tracking bulletins, no images, no comment on the growing speculation surrounding the ring structure, and more importantly, no denial. This wasn't just unusual, it broke their pattern. Normally, if something controversial begins gaining traction, especially if it's based on amateur images or foreign sources, NASA responds. They'll correct it, explain it, offer a natural explanation. The agency has entire departments built around public trust in data, but this time they didn't. Instead, the Deep Space Network, the system used to coordinate observation of objects across the solar system, shifted its scheduled tracking of 3I Atlas to a closed session. The live stream of positional telemetry that had been updating every few hours went dark, not removed, just delayed, buffered, lagged. And when reporters reached out for comment, the language became colder. One internal NASA media liaison simply replied, "We are continuing our standard observations. No unusual activity to report at this time. No mention of the ring, no acknowledgement of the image, no hint that anything had changed." But behind closed doors, researchers began whispering. Within a private Slack workspace used by exoplanet scientists and deep sky observers, one message began circulating like wildfire. JPL has redacted 4 frames from the near-perihelion sequence. The files are now password-gated. That raised red flags, immediately. The Jet Propulsion Laboratory rarely restricts observational data, especially not comet telemetry, which is considered low sensitivity and usually public. Yet, the logs now required authenticated credentials tied to specific government accounts. Scientists who had been studying 3I Atlas for months suddenly found themselves locked out of the most recent data. Worse still, internal radiometry logs from the Goldstone Solar System radar, normally redundant with data from Arecibo and Canberra, stopped updating entirely. It was as if the world's most well-funded space agency had hit a pause button. And for the first time since the interstellar visitor entered our solar system, NASA went quiet. This silence was not neutral. It had weight. Because when an agency stops talking about an object they were previously tracking hourly, it means one of two things. They've seen nothing, or they've seen something they cannot or will not explain. And right as that silence deepened, China's firewall went up. The original image vanished from the public archive. Access to the Langfang server was revoked. And what had been a quiet anomaly seen by a handful of analysts suddenly became something more. In the absence of answers, speculation exploded. Some believed the object had split. Others suggested it was emitting a focused beam. The more grounded voices pointed to high albedo dust rings or rare plasma halos. But all of these interpretations ran into the same problem. They assumed NASA hadn't seen the same thing China had. But they had. Their tracking systems are too advanced, their visibility too constant. The James Webb Space Telescope had eyes on 3I Atlas from multiple positions. SOHO's LASCO instrument had full line sight, and the Parker Solar Probe had passed within observational proximity just days prior. So if they saw it too, and said nothing, it wasn't because they didn't know. It was because they didn't want us to know what they saw. The silence became louder than words, and for the scientific community watching carefully, the absence of explanation said more than any press release ever could. When the image first appeared, most people saw it as strange. But when scientists began measuring the shape, they realized it was something far more precise. The ring wasn't just a glow, it was geometry. Clear, measurable, and unnaturally stable. And that's where the real problem began. In a natural comet, the so-called coma, the cloud of dust and gas that surrounds the nucleus, forms unevenly. Sublimation drives out jets in all directions, but solar heating causes most of the activity to concentrate on the side facing the sun. What you get is a hazy, chaotic bloom, irregular and constantly shifting. The edges are diffuse, the light scatters randomly. But the structure around 3I Atlas wasn't diffuse, it wasn't chaotic. The ring measured out as a uniform arc, consistent across both vertical and horizontal axes, with less than 2 degrees of deviation in curvature from its central point. And even more concerning, it wasn't expanding or trailing like normal sublimation material. It was holding its form. Imagine this. If you were to draw a circle around the object using its brightest light emissions as anchor points, you'd end up with a perfect fit. Something that simply shouldn't happen in nature. Natural jets wobble, dust trails drift, rings break apart, but this one didn't. It remained coherent even as the object moved, and that's where geometry begins to whisper intent. Let's break this down. In orbital mechanics, any symmetrical structure that persists under solar radiation pressure must be either bound by gravitational cohesion, unlikely for a transient cloud, or maintained by some internal stabilizing force. But comets have no such force. They tumble, they vent, they break, yet the ring held steady. Worse still, the symmetry was axial. When a Chinese observatory applied isophotal analysis, a technique used to map equal levels of brightness, the contours didn't blur outward. They bent into concentric curves around a central spine. A spine that coincided perfectly with the object's apparent direction of motion. This is where things become deeply unsettling for those who study light interaction in space. The ring emitted no spectral fingerprints that matched dust. There was no silicate scatter, no strong water vapor signal, no elevated carbon monoxide trace that would suggest active venting. It was simply glowing, softly, evenly, as if reflecting, not radiating. And that raises the unspoken possibility: what if the ring isn't made of particles at all? What if it's structural? One astrophysicist writing anonymously in a physics forum proposed a possibility that still sends chills through the scientific community. The ring is too smooth for particle diffusion. If it's coherent light reflection, then we may be looking at a physical structure, a circular array or surface, designed to deflect or regulate energy. He didn't call it alien. He didn't have to. Because at that point the geometry was doing the talking. Consider what kind of engineering would be required to maintain a symmetrical light-scattering surface during solar approach. The shape would need to adapt to radiation flux, maintain thermal equilibrium, and remain aligned relative to both its axis of motion and the source of radiation. That's not accidental. That's not debris. That's architecture. So what are we looking at? A frozen halo, a toroidal dustband, a magnetic field trapping ionized particles in a torus. Every explanation falls short. Because dust doesn't hold geometry under radiation, gas doesn't emit evenly from multiple angles unless it's being funneled, and light doesn't scatter in uniform circles unless there's something smooth, something solid beneath it. Which means this isn't just a visual oddity, it's a mathematical one, and mathematics doesn't lie. When it comes to observing objects in deep space, no two instruments see exactly the same thing. Differences in atmospheric conditions, sensor sensitivity, and orbital perspective can all influence the final image. But in the case of 3i Atlas, something more fundamental began to surface, something that went beyond perspective. The spectral data from China's observatories did not match what Hubble was reporting, and the differences weren't subtle. Spectral bands are the fingerprints of objects in space. They tell us what materials are present based on how light is absorbed and reflected across different wavelengths. Hydrogen, oxygen, carbon dioxide, and dust each leave their own distinct marks. Normally, even across different observatories, the shape of the signature remains consistent. The intensity may vary, but the chemistry does not. But on December 21st, the infrared spectrum captured by China's Langfang Observatory returned something unusual. A strong narrow spike in the near-infrared band, centered around a wavelength that did not correspond to water, carbon dioxide, or any of the usual comet signatures. In other words, a spectral anomaly. That spike, recorded at multiple timestamps in a filtered wavelength channel, was absent in Hubble's data from the same observation window. The James Webb Space Telescope, with its superior infrared resolution, showed a standard profile, elevated carbon dioxide, trace water vapor, and dust scatter, all within expected tolerances. But Langfang's spike shouldn't have been there, unless the object was emitting something momentarily from a direction or mechanism that Hubble couldn't see. Some researchers argued this was simply a matter of viewing angle. Hubble, in orbit around Earth, may have had a different line of sight than Langfang, but that doesn't explain the intensity of the spike. The spectral anomaly was narrow and consistent, lasting for over 12 minutes across multiple exposure windows. A natural event, like a jet of gas or a sudden burst of particles, wouldn't last that long without also appearing in visual wavelengths. But there was no visual flare, no dust expansion, just a quiet, narrow band of infrared heat that didn't match any known cometary behaviour. And then came the second problem: polarization. The Chinese observatory logged a polarized reflectance reading, light bouncing off the object in a preferred direction. This effect can happen naturally, but usually in chaotic ways. Dust scatters light randomly, ice reflects weakly. But here, the polarization was coherent, aligned, suggestive of a flat or curved surface redirecting light consistently. NASA didn't report that. In fact, when side-by-side comparisons of the same object, from the same time frame, were laid out by an independent data analyst group, they showed an eerie contradiction. The Langfang image showed a ring of emission in the near-infrared, while Hubble's output showed a clean, structureless coma. The disagreement wasn't minor, it was central. So what caused it? One theory proposes that the object emitted, or reflected, a controlled infrared pulse at an angle only visible from the eastern hemisphere. This pulse may have been caused by a heated surface cooling under radiative stress. Another proposes something stranger, that the object was selectively interacting with solar radiation, using a surface layer composed of engineered materials, carbon mesh, metallic coating, or conductive skin, that briefly activated in infrared under solar flare pressure. That explanation sounds like science fiction, but it's one of the only models that matches the observed data. So now we're left with a contradiction. If Hubble is right, the object is just a comet, a strange one, but natural. If China's observatory is right, it's emitting signals or reflecting light in ways that natural objects don't. Both can't be right, unless of course something changed on the object between those two observations, or something was filtered out. Either way, the spectrum has split, and somewhere between infrared silence and a glowing spike, the truth is hiding, quiet, precise, and just out of reach. Comets have tails, that's the rule. When an icy body approaches the sun, the intense radiation causes its surface to heat, releasing gas and dust that stream away from the nucleus. This stream forms two distinct features: a curved dust tail pushed by sunlight, and a straight ion tail pushed by the solar wind. It's been seen 1,000 times before, but what was seen trailing 3i Atlas didn't behave like a tail. The first reports came from a group of amateur astronomers in Japan using long-exposure stacking methods. When they captured a sequence of 3i Atlas moving across the sky, something stood out immediately. The structure following the object didn't blur outward or feather into space like a natural coma. It stayed tight, narrow, and unnaturally coherent. Instead of trailing behind the object, it moved with it, like it was connected. Professional observatories noticed it next. The Solar Terrestrial Relations Observatory, STEREO-A, which had been monitoring solar-wind interactions, recorded something bizarre. A bright tapering stream that refused to bend with the solar field lines. In every standard model, a comet tail bends. As the object turns, the tail swings, delayed and dragged by momentum. But this stayed centered. It looked less like a tail and more like a structure, something fixed, something rigid. And even more strangely, it glowed. Most comet tails glow by scattering sunlight or fluorescing as ions are excited. But 3I Atlas's stream didn't pulse or flicker. It didn't scatter. It emitted light at a steady rate across a narrow band of the spectrum, one that didn't align cleanly with expected molecular emissions. The glow came not from chaotic dust, but from something smooth, uniform, almost like a sheath. One team of observers at the Max Planck Institute ran simulations to try to replicate the brightness curve. Their findings were unexpected. The brightness behind 3I Atlas could only be matched by a semi-reflective surface extending hundreds of kilometers outward. Not by dust, but by a form, a surface. Something with edge coherence. In simpler terms, they weren't seeing a tail. They were seeing an object trailing the nucleus, attached or hovering in alignment, like a sail or a stabilizer. One researcher compared it to an airplane's contrail that refused to dissipate. Another said it was like watching a blade moving through vapor, sharp, focused, and wrong. Even more troubling were the thermal readings. The James Webb Space Telescope picked up faint infrared emission along the stream. Not dust, not gas. Heat. Uniform, narrowband, directional heat, emitting like a passive radiator. That doesn't happen in comet tails. Natural tails don't emit steady heat signatures. They flicker, pulse, scatter light unpredictably. They don't hold a shape. And they certainly don't maintain alignment over dozens of frames taken hours apart. Yet here it was. A glowing stream, not trailing, not scattering, but holding. Staying locked behind 3I Atlas like a tether or a spine. If it's not a natural tail, then what is it? Some suggest it could be a thin layer of magnetic particles aligned by an onboard field. Others speculate it's a light-reflecting shield or radiation sail, purpose-built to collect or redirect solar energy. The most extreme theory is the simplest one. It's part of the object. A wing, a fin, a stabilizer. Because at this point, there's no natural process that accounts for a structure that moves with the object, glows without dispersing, and maintains thermal consistency. The glowing trail of 3I Atlas defies the core principles of comet physics. It doesn't behave like dust. It doesn't behave like gas. It behaves like design. If you've ever studied comets, you know how their tails work. As sunlight and solar wind push against a comet's coma, the dust and ionized gases stream outward, away from the sun. The direction of that tail is a consequence of physics, radiation pressure, solar wind vectors, orbital speed. It always flows anti-solar. That's not just expected, it's universal. And yet, 3I Atlas doesn't seem to care. In multiple images taken from observatories in Chile, South Korea and India, a strange feature keeps emerging from the comet's forward-facing side, a thin, concentrated filament of material that defies every known model of tail formation. It doesn't trail behind, it points toward the sun. Astronomers call this an anti-tail. In rare cases, traditional comets have been seen to produce backward-pointing features due to optical illusions caused by particle dispersion and Earth's angle of view. When large dust particles lag behind the comet in its orbit, and Earth crosses the orbital plane, those particles can appear to line up between Earth and the comet, creating a spike that seems to point toward the sun. But that explanation only works under very specific conditions. With 3I Atlas, the anti-tail kept showing up, across multiple angles, different latitudes, and independent observation arcs. As Earth moved in its orbit, and viewing geometry shifted, the anti-tail remained. It wasn't a viewing trick, it was real. It was material moving toward the sun rather than being pushed away from it, and that changes everything. Because the only way to create a persistent anti-solar stream is to actively eject material in that direction, against the natural flow of solar pressure. That means thrust, That means propulsion. That means control. At the Indian Institute of Astrophysics, a polarimetric analysis was run on one of the high-resolution anti-tail images. The data revealed polarization signatures consistent with aligned reflective particles, not diffused dust. These particles weren't tumbling chaotically in the solar wind. They were oriented, as if they were being shaped or steered. Meanwhile, an even more disturbing detail began to emerge. The anti-tail wasn't centered perfectly along the solar vector. It was offset just slightly, by about 4 to 6 degrees, matching the trajectory correction 3I Atlas experienced during perihelion, when its course suddenly deviated away from predicted models. The implication? The anti-tail may have been the cause of that course change. Let's step back and consider that. What if the object ejected mass sunward, not as a byproduct of heating, but as a reaction to create forward thrust? That would mean 3I Atlas used the sun not just as a source of energy, but as a slingshot, redirecting its motion deliberately, like a probe adjusting trajectory using a chemical burn. Natural comets can't do this. They don't think, they don't steer, they don't respond. And yet, the geometry of the anti-tail seems to do just that. It lines up not with chaos, but with purpose. Some researchers, speaking off record, have begun referring to this as the sunward vent hypothesis. The idea that 3I Atlas contains a mechanism, natural or artificial, that vents material toward the sun to change its vector away from it. The anti-tail isn't waste, it's function, and it aligns disturbingly well with models of early-stage solar sail thrust or exhaust vector guidance. This recurring anomaly is no longer fringe. It's now been recorded by over a dozen instruments at multiple wavelengths, under different conditions, and each time the anti-tail returns, pointing not away, but back to the source, back to the sun. And in doing so, it points us to something even more disturbing, that 3I Atlas may not just be surviving the sun, it might be using it. In the world of comet science, jets are a known phenomenon. As sunlight heats the surface of an icy nucleus, pressurized gas bursts through cracks in the crust, releasing plumes of vapor and dust into space. These jets form randomly, usually emerging from weak spots on the surface. They're chaotic, irregular. They change as the object rotates. They're noisy, both in how they appear and how they behave. But the jets on 3I Atlas don't behave like that at all. Shortly after its perihelion in late October, high-resolution images from both Chinese and South African observatories began to show something odd. Jets were visible, but they weren't chaotic. They were aligned, stable, consistently emerging from the same regions of the object's surface, not rotating, not fluctuating, not flickering out. 3 primary jets were identified, spaced with nearly equal angular separation, emerging from the forward hemisphere of the object. They maintained fixed angles relative to the object's center of mass. Their velocity and brightness levels remained nearly identical across several observational windows, including shifts in heliocentric distance. In simpler terms, they weren't changing, even as the environment around them changed. That doesn't happen in natural comets. Even under ideal conditions, outgassing shifts as a comet moves away from the sun. The activity fades, jets weaken. But here, 3I Atlas appeared to stabilize after its solar encounter. The jets didn't fade, they became more consistent. One observatory even recorded a moment where the jets seemed to intensify in unison, just hours after a solar flare struck the upper corona. This led to one particularly disturbing hypothesis, that the jets were reacting to external energy, not passively, but functionally, like thrusters activating in response to a solar event. Let's examine what this means. In natural comet physics, jets are driven by sunlight, but sunlight doesn't hit every part of a comet equally. Spin, axis orientation, shadowing, and surface topology all cause uneven heating. That's why most comets vent unpredictably. But 3I Atlas's jet output didn't show those inconsistencies. Its orientation remained constant. The geometry of the jets didn't vary, even when the angle of solar incidence changed. Now, in engineering terms, that's called a controlled exhaust pattern. And in propulsion modelling, it's exactly what you'd expect from a system designed to steer or accelerate. So, are we seeing propulsion? We might be. Because if the object is deliberately venting mass from fixed points in fixed directions, then we're not looking at random sublimation anymore, we're looking at vector thrust. And here's what makes that even more chilling. Using the velocity of the jets, estimated at just over 200 meters per second, and the observed deviation in 3I Atlas's orbital path after perihelion, one research team calculated that even a small, sustained release of mass over 24 hours could produce exactly the trajectory shift seen on November the 1st. The math fits, the timing fits, and the jet orientation, nearly opposite the observed vector deviation, fits perfectly. It's not proof of intent, but it's no longer explainable as coincidence. These jets are too clean, too directional, too organized. There are no irregular flares, no crumbling debris fields, no spin-induced wobble that would account for venting randomness. Everything about them is stable, deliberate, functional. Whether it's a natural mechanism we don't yet understand or a technological system we're not prepared to acknowledge, one thing is certain. 3I Atlas is not just leaking gas, it is using it. The first to notice it were amateur astronomers in Mongolia and Kazakhstan. While scanning near infrared frequencies, they observed something peculiar, light reflecting from 3I Atlas at regular intervals, like a heartbeat pulsing through space. At first they dismissed it. Interference. Instrumental noise. But then, independent observatories began confirming it, and then China's Deep Space Relay Station locked in on the same signal. Not a transmission, not a radio ping, a reflection. This isn't about noise, this is about light, reflected light, bouncing off 3I Atlas with astonishing regularity, producing a rhythmic signature that doesn't fit anything we've catalogued before. The signal wasn't steady, like a mirror constantly pointed at Earth. Instead, it appeared and disappeared, on a loop, a pulse that returned every 12 minutes and 4 seconds, with startling precision. This is where the science started to unravel. Comets don't reflect light like this. Their surfaces are uneven, porous, dusty. Even large bodies like Halley's Comet scatter light in irregular patterns, depending on their rotation, gas output, and changing albedo across the nucleus. But the reflective signature from 3I Atlas wasn't chaotic. It was structured. A clean, repeating waveform, bright, dim, in what scientists called a tidal mirror profile. The working theory: there's a smooth surface, likely convex, rotating or shifting in such a way that it catches sunlight at a consistent angle and reflects it straight back to Earth. And it's happening with such stability that some teams suspect the reflecting material might not even be dust or rock, but something engineered. Perhaps metallic, perhaps crystalline, perhaps a configuration we've never seen in a natural body. What makes this more unsettling is the rhythm. Nature doesn't do perfect timing like this. Not at this scale, not across multiple observation points. The odds of a natural surface producing a 12-minute reflection cycle that holds across thousands of kilometers, dozens of angular shifts, and over 20 continuous hours of observation. Statistically improbable. And yet, it happened. On December 17th, Chinese analysts began to notice that this rhythmic reflection was slightly phase-locked with the previously recorded heat signatures. That means the reflective pulses matched with slight temperature oscillations on the object's surface, suggesting not only synchronization, but coordination. This is no longer a simple comet with a shiny spot. It's now something that may be actively modulating its surface reflectivity in response to solar input. Why would it do that? One possibility: communication. Not with us, but with something else. Using simple solar reflection, an object could signal by modulating its albedo pattern, creating a primitive light code across interplanetary distances without using radio. Another possibility: camouflage. By adjusting reflectivity at intervals, it could mimic natural glint patterns and blend with other space debris or celestial objects. And the most chilling theory: it's a control mechanism, a way to regulate internal temperature or radiation exposure through dynamic surface adaptation. We still don't know, but what we do know is this: something on 3I Atlas is flashing back at Earth. Not once, not randomly, on schedule. And as we approach its closest orbital intercept, the pulses are becoming stronger, not fainter. We are seeing more energy in each reflected wave, suggesting the surface system, whatever it is ramping up. This isn't just a curiosity anymore, it's a signal of behavior, not chaotic, not passive, not natural. This is something with intentional rhythm, and it's watching the sun, just like we are. When China detected the light pattern, it didn't take long for their highest orbital observatories to shift full attention to 3I Atlas. The National Space Science Center in Beijing diverted 3 independent satellite arrays within 36 hours. But what followed was not a flood of new data shared with the global community. It was an eerie silence, and then a lockdown. On December 18th, a routine data sharing request from ESA's Solar Orbiter team was denied. No reason given. Hours later, researchers at Japan's JAXA reported a complete blackout on scheduled information packets from China's Deep Sky Relay system. This wasn't a glitch. This was deliberate. The entire 3I Atlas tracking node in the National Astronomical Observatories of China went offline. The signals stopped. The reports stopped. And all access portals tied to the object's updated light curves, plasma scans, and spectral imaging were suddenly listed as under re-evaluation. It was as if China found something, and then immediately decided to shut the door on everyone else. Now here's where things get even stranger. Satellite weather logs showed that there was no interference, no solar storm, no space weather event that could have affected their data. The sky was clean. Their systems were operational. So what caused the shutdown? Insiders, speaking anonymously to independent reporters, claimed that a preliminary analysis conducted within the Chinese Lunar Research Base identified a structural configuration on 3I Atlas that did not align with any known natural comet geometry, something that appeared to have symmetry, straight lines, angles, and segmentation. That single term, symmetry, is what triggered the silence. According to one leak, the object's surface returned a radar echo that showed internal cavities spaced at mathematically uniform intervals, like the ribs of a lattice or the chambers of a modular shell. It mirrored some of the theoretical frameworks proposed for artificial asteroid mining platforms. Not a natural body, not a comet, but an engineered shell. After that finding, the Chinese research teams were reportedly ordered to freeze all outbound reporting. No press statements, no papers, no shared access. And even stranger, all references to 3I Atlas were quietly removed from Chinese academic portals. Web pages listing spectrographic results went dark. Imaging databases vanished. One by one, China began pulling itself out of the public dialogue. Why? One theory is internal caution. They wanted to avoid premature conclusions. Another, more chilling theory is control. If they believe the object might be of artificial origin, they may see it as a national interest asset, something that could be studied in secrecy, claimed, or potentially even influenced. Regardless of the motive, the outcome is clear. China knows something, and whatever it is, they're not sharing. This silence has sparked a wave of paranoia across observatories worldwide. If one major power decides to lock down all observations about a comet that might not be a comet, what happens next? Are we entering a new kind of space race? One where the finish line isn't a planet or a moon, but an unknown object entering our solar system. One that's behaving just a little too perfectly, and one that's now being watched in silence. On December 18th, a narrow-band frequency spike was recorded by China's Deep Sky Surveillance Array, an unpublicized telescope system located in Gansu Province, primarily used for deep space radar tests and Lagrangian monitoring. The object of interest, 3I Atlas. What made this event unique wasn't just the signal itself, it was the precision of its rhythm. The spike came in at regular intervals, 7 pulses, identical spacing, identical amplitude, identical decay curves. This wasn't background noise, it wasn't cosmic interference. The data signature showed clean modulation, tighter than the signature of any known natural pulsar or rotating neutron star. The array had been quietly tasked with monitoring 3I Atlas since China's mid-November discovery of the organized jets. But when this signal emerged, something shifted. It wasn't just an echo from a solar flare. The pulse spacing was out of sync with known energetic emissions from the Sun. It didn't match any Earth-orbiting satellite echoes, and most crucially, it did not repeat after the first 7 bursts, just once. 7 tones, then silence. The team monitoring the array performed a series of cross-checks. They ruled out aircraft, local RF interference, passing satellites, even atmospheric ionization artifacts. The frequency band itself, around 20 MHz, is unusual for natural emissions but ideal for short-range directional transmission through a vacuum. So what were they hearing? The working hypothesis: a low-power, targeted emission, either sent from the object itself or reflected through a rotating surface synchronized with internal timing. This is where the Chinese data stunned even external analysts, because the 7 bursts matched not just a uniform interval pattern, but one that appeared nested. That is, each signal wasn't a single tone, but a cluster of sub-pulses inside a broader carrier wave. Think of it like a chord, not a note, multiple harmonics inside one message, 7 chords in total, each just under 1 second in duration, and within each, tiny shifts in amplitude and waveform, suggesting an encoded modulation system. No known natural object does that. Not asteroids, not comets, not dying stars. The only analogues in physics are artificial, communication protocols. It was subtle, almost too subtle to matter, unless you know what to look for. And that's when the team noticed something else, the angle of signal reception. The pulses were detected only when 3i Atlas passed through a very narrow arc of sky, just under 5 degrees wide. Outside of that, the signal was gone, which meant the emission wasn't spherical. It wasn't radiating in all directions like a star. It was beamed, directional, as if targeted at something, or someone. The researchers knew what this implied, not just an emission, but intent. Whether it was an automated signal or a decaying relic from a long-dead probe didn't matter. It was real. It was structured. And it was coming from a comet that already defied every known model of interstellar behavior. The moment Chinese scientists uploaded a sanitized summary of their December 18th signal analysis to their secure academic exchange, NASA stopped talking. No press statements, no updated tracking logs, no new orbital telemetry, no infrared burst warnings. Nothing. It was as if a global mute button had been pressed. This wasn't speculation. Several professional astronomers across Europe and South America confirmed that NASA's internal communications portal, used for observational syncs across international collaborations, had gone read-only for 3 straight days. That had never happened during an active comet pass in over 15 years, and when questioned, NASA responded with a standard legal disclaimer: data is undergoing recalibration. But the timing didn't line up, because just 2 hours before the blackout began, the European Space Agency had published an innocuous report about 3i Atlas's trajectory shift. Nothing controversial, just a velocity change. But that report included a time-stamped orbital map, one that showed a deviation aligning with the exact window of the 7-tone burst China had logged. In other words, Europe had confirmed the comet moved right when the signal emerged, and then silence. Every academic who asked about the Chinese signal received the same response: no comment. Even senior radio astronomers from Australia and Chile, who had no reason to be bound by US policy, began withdrawing public comments. Something was spreading behind closed doors. Was it fear of panic? Was it classification? Or was it something more chilling? Knowledge of a pattern repeating itself. You see, back in 2017, after Oumuamua passed Earth, a similar blackout occurred. No signals were confirmed publicly, but key astronomers involved in the initial tracking suddenly changed fields. Quiet exits, early retirements, projects cancelled. The pattern was repeating, and 3i Atlas was bringing it back into the light. For now, the silence only raised more questions, because when every institution suddenly refuses to speak, that itself becomes the loudest signal of all. In the quiet tension that followed the radio blackout, something curious happened inside the private astronomy forums used by observatories across Asia and Europe. A low-profile data analyst in Taiwan, working under a university research program not bound by national space contracts, posted a speculative chart. It was a waveform map, plotting the 7-tone burst China had captured on December 18th. But this analyst did something no one else had dared. He tried to overlay those frequencies onto a stellar coordinate system. And what he found sent a chill through those watching. Each tone, when translated from its signal timing and frequency variance, could be mapped onto a 3-dimensional spatial vector, as if the signal wasn't just audio, but a positional sequence, a coordinate system disguised as rhythm. The spacing between the tones corresponded to angular deviations. The amplitude shifts mirrored known phase drift patterns caused by relativistic motion. In short, what looked like a random burst of energy might actually be a navigation key. To what? We don't know, but the map, if that's what it is, points to 7 distinct locations in the local galactic cluster. Not planets, not stars, but empty regions of space with no known mass signatures. Unless, of course, they're cloaked by something we don't yet understand. This is what's now being called the 7-tone map theory. Not a message to Earth, not even a message from the object, but a signal, a relic, broadcast through 3i Atlas, designed to be intercepted only under exact positional conditions, like a cosmic dead drop, a lighthouse that flashes its beam only when the tide is right. If the analyst is correct, and even senior physicists have admitted the math is compelling, then the signal's content wasn't a message, it was a map, a beacon to something bigger, and perhaps far older. It wouldn't be the first time ancient civilizations on Earth used rhythm and position as encoded knowledge. Think of megalithic structures aligned to stars or ancient glyphs whose pattern only made sense from above. This would be the cosmic scale equivalent. But here's the twist. After the post went live, the analyst deleted it. Not just the chart, but his entire forum presence. Even his university email bounced, and within 12 hours all archived versions of the waveform map were taken offline. Only screenshots remain, passed hand to hand, whispered about in hushed tones across telescope control rooms and encrypted chat channels. Was it a hoax, or was it too close to the truth? Either way, the theory remains: 7 tones, 7 vectors. A directional guide embedded inside an interstellar object masquerading as a comet. And if it's true, then 3i Atlas isn't just passing through our system, it's pointing to something beyond it. As researchers struggle to understand the implications of the 7-tone map theory, another idea, one long dismissed as fringe, suddenly re-entered scientific conversation: the cloaked mass theory. First proposed during the post-Oumuamua analysis in 2018, the cloaked mass theory suggested that some interstellar objects might not be objects at all, but distortions, artificial or otherwise, designed to mask larger bodies or structures from optical and infrared detection. The idea had fallen out of favour because it lacked direct evidence. But with 3i Atlas, something changed. After the signal incident, multiple infrared telescopes, most notably China's Fengyun 7B and Japan's Himawari infrared array, reported brief detection anomalies in the shadow zone of the comet. These weren't thermal signatures from the comet itself. Instead, they were negative space distortions, localized gaps in heat radiation, as if something was absorbing or redirecting background infrared light. The shape of the anomaly wasn't consistent with any known debris field. It was narrow, curved, and it moved with the comet, not in front of or behind it, but beside it, like a shadow moving independently of light. This was the first observational evidence supporting the idea of adjacent mass cloaking, something that could bend electromagnetic radiation in such a way that it left no signature, not even from behind. Now, with the 7-tone signal possibly pointing toward mapped coordinates, the cloaked mass theory gained momentum. What if 3i Atlas is just the anchor, a small probe hiding the wake of something larger? Or worse, what if the object riding beside it isn't a structure at all, but a vessel? One that uses the comet's natural appearance as camouflage. A Trojan horse drifting through solar systems, not to attack, not to land, but to listen, to wait. Because if you're an ancient intelligence and your tech has survived deep time, you wouldn't blast signals across the galaxy. You'd hide, you'd drift, you'd use objects that look natural until they're not. Cloaked mass wasn't just science fiction anymore, it was data, incomplete, but real. And those tiny ripples in the infrared vacuum, they might be the only visible proof we've ever seen of something deliberately hidden in plain sight. With every new anomaly, scientists hoped to find patterns they could explain. Instead, 3i Atlas gave them something worse, a signal buried so deep in the noise that it shouldn't have been detectable at all. It came from the University of São Paulo's low-orbit spectral analysis satellite, Aurora 3. Tasked with measuring background hydrogen resonance across polar magnetic fields, the satellite was never meant to track comets. But on December 19th, as 3i Atlas made its closest approach to Earth's orbital plane, Aurora's instruments picked up a harmonic frequency divergence, one that lasted less than 0.4 seconds. It was a layered waveform not unlike those used in Earth-based sonar, except it occurred in vacuum. No medium, no acoustic carrier, and it matched none of the previous 7 pulses. This wasn't a repeat. It was a different kind of signal entirely. The signature showed what researchers called a resonant cascade, a tiered series of frequency steps, each doubling in harmonic intensity, then collapsing into silence, like a ladder being climbed and then erased. Aurora's data team initially flagged it as instrument error, but when cross-referenced with a simultaneous anomaly from a French high-altitude balloon experiment over Antarctica, one that recorded magnetic flutter during the same time window, something became clear. This harmonic event was real, and it wasn't just electromagnetic. It appeared to influence local magnetic density. That is, it briefly altered the shape and intensity of Earth's magnetosphere at high altitude. No known comet has ever done that. Some theorists now believe this harmonic event may have been the real transmission, a deeper signal encoded not in frequency, but in resonance behavior. Like a key played through the physics of space itself. If true, it would mean the comet isn't just sending information, it's triggering responses in the environment, and it's doing so in ways we don't yet understand. This wasn't a broadcast, it was a test, and Earth just responded. As the data feeds continued flowing into China's Deep Sky Survey array, one particular anomaly in the latest batch of readings set off a silent alarm. It wasn't a visual flash or a heat signature spike, but something far more peculiar, an unaccounted for increase in local gravitational distortion. The region around 3I Atlas, as mapped through high-resolution interferometry, showed a sudden density variance that contradicted all existing models for icy interstellar objects. In simpler terms, something inside the object had changed its mass distribution, without shedding debris or showing signs of fragmentation. This wasn't just a mathematical curiosity, it meant the internal structure of 3I Atlas had either compacted unnaturally, or something denser had shifted within it. Chinese researchers ran simulations for hours, trying to recreate the readings. They tested cometary cores with pockets of heavy metal. They modelled fragment impacts. Nothing matched the slow, steady internal weight shift they were seeing. A comet shouldn't behave like this, and the longer they watched, the more the mass centre appeared to be adjusting. The speculation began quietly at first. Could it be a core made of something non-natural? A geometric frame rotating inside? Something designed to remain balanced until a certain point? All of this sounded like science fiction, until the data showed another shock. The magnetic field lines around 3I Atlas were being pulled ever so slightly by something within. The object didn't just weigh more, it behaved as though it were controlling that weight. That alone should have made global headlines, but instead the team filed their report internally. No press conference, no release, and no coordination with NASA. The silence wasn't just noticeable, it was intentional. What followed next was perhaps more revealing than the data itself. Normally, when a country stumbles on something this potentially historic, a discovery that challenges natural formation models, there's at least some form of academic collaboration. A paper, a conference abstract, a satellite handoff. But from Beijing's National Astronomical Center, there was nothing. No external communication, no media briefings, no informal chatter in global research channels. Instead, they quietly increased telescope time on the object. They upgraded cloud storage allocations for their 3I Atlas folder, and curiously, one of their most senior astrophysicists, someone with deep ties to military-grade optical satellite programs, was suddenly added to the tracking team. The move raised eyebrows among insiders, not because it was wrong, but because it was strategic. From outside observers, it began to feel like a pattern, the density shift, the controlled silence, and now the inclusion of defense-level optical analysts. Some speculated the Chinese Space Agency had seen enough to consider this more than a comet. They weren't just studying it, they were classifying it, and that meant the flow of data, at least publicly, would soon stop. Meanwhile, the US remained quiet. NASA's Jet Propulsion Laboratory made no new public mentions of 3I Atlas after December 18th. And that was odd, especially considering the recent increase in signal traffic across deep space listening arrays. Why was everyone stepping back from the microphone at the same time? What could possibly justify such synchronized silence between superpowers with competing space agendas? The theory forming in the shadows wasn't comforting. Maybe they'd all seen the same thing. and maybe they agreed. It shouldn't be shared. The most subtle sign that something had shifted behind closed doors came not from what was said, but from what stopped happening. Ground-based observatories, especially those operating under international partnerships, started reporting issues with data access. Researchers in South Korea and Australia, for instance, noted that their scheduled windows for observing 3I Atlas were being overridden or suddenly reprioritized by larger facilities. This wasn't normal. Space coordination is often messy, but it's rarely secretive. Normally, when observing time changes hands, there's a traceable reason, another object in urgent need of tracking or bad weather forecasts. But here, there were no such explanations, just blank notices, cancelled passes, priority uplinks suddenly disabled without discussion. Even amateur astronomers began noticing strange behaviour. Forums that had once been filled with 3I Atlas chatter fell quiet. A few reported being contacted by local astronomy clubs, advising them to deprioritize 3I Atlas and move on to other observable targets. Some of these clubs were linked to university telescopes, which themselves had ties to government-funded research networks. In hindsight, it all added up to one thing: coordination, the kind that doesn't happen organically. From the outside, it looked like access to 3I Atlas wasn't just being limited, it was being curated, whether through military directive, private security protocols, or classified-level rerouting. This object had moved beyond being just a comet. It had become something more, something sensitive. And sensitivity in space science doesn't come from ice and dust. It comes from the unknown. And right now, the unknown was sitting right at the heart of this object. And every major power seemed to know it. When the Chang'e Deep Space Array captured another high-frame scan of 3I Atlas on the morning of December 21st, they weren't expecting anything new. But what they found in the rotational data changed everything. Again. It wasn't just spinning, it was wobbling, but not randomly. The spin axis had shifted slightly, and it was now oscillating in a way that indicated active torque, a force being applied from within. Now, in natural objects, this can happen due to venting gas jets or solar tidal forces, but the spin characteristics of 3I Atlas no longer fit those models. The periodicity of the wobble was unnaturally smooth. It wasn't decaying or responding to sunlight, it was stabilizing. In short, it looked programmed. This kind of dynamic behavior had never been seen before in an interstellar body. Even Oumuamua, the first known visitor from beyond our solar system, exhibited a chaotic, tumbling rotation. Nothing like the refined, guided pattern that 3I Atlas now displayed. Chinese engineers, using software originally designed for tracking space debris, simulated a rotating internal frame, something like a gyroscope. Their model matched the movement, a gyroscopic core inside an interstellar comet. It was a phrase that made some people in the room go silent. If that's what they were seeing, then this wasn't just about the object anymore. This was about who or what might have sent it. The silence nearly held, but not completely. From within the Xi'an Remote Sensing Laboratory, an observatory connected to both civilian and military-grade optics, a single unverified leak broke through the firewall. A technician, who remained anonymous, but posted through a temporary account on a Chinese-language scientific forum, claimed to have seen an internal slide deck prepared for senior space officials. The presentation, according to this leak, included the phrase, "Origin Design Unknown." It went on to mention suspected symmetry patterns within core imaging, and the need for ongoing spectral secrecy due to foreign observation risk. In less coded terms, someone found shapes, possibly geometric or artificial looking, inside 3I Atlas, and they didn't want anyone outside China seeing them. The post was deleted within 3 minutes, but not before screenshots spread. The images weren't conclusive, and they were quickly buried by official posts from automated accounts. But to those watching closely, it was a crack in the wall of silence. A confirmation that someone somewhere had labelled this object not as a natural wanderer, but as an engineered anomaly. And if it really was engineered, then we were no longer just looking at astronomy. We were staring straight into the heart of a design we couldn't explain. As December 21st turned into evening, something strange settled over the global space community. No statements were made, no new alerts, no images released, not from NASA, not from the Chinese National Space Agency, not even from the private satellite networks that usually fill the gaps when governments go quiet. It was as if the entire sky had gone still. But the comet hadn't. 3I Atlas continued moving, continued pulsing with that same soft glow it had carried since its pass near Jupiter. Its tail had stabilized, its anti-tail shimmered with almost metallic regularity, and its trajectory remained unchanged, toward Earth, slow and silent. In the absence of facts, speculation grew. Was this silence designed to protect us, or to protect them? Had someone decided the public couldn't handle the implications of an engineered object crossing into our solar system? Or worse, had a decision been made not to communicate because this wasn't a message for us at all? Sometimes silence is the loudest sound in the universe, and 3I Atlas was speaking with it, clearly. There are moments in human history when we find ourselves looking outward, toward the edge of understanding, and something looks back. But it doesn't wave, it doesn't blink, it doesn't announce itself with the clarity we want. Instead, it arrives in the form of silence, or worse, a pattern we almost recognize. 3I Atlas has become exactly that kind of moment. When it first streaked into the outer edges of our system, scientists were cautious. It wasn't the first time a deep space object had entered our cosmic neighborhood. It likely won't be the last. But where previous visitors like Oumuamua or Borisov hinted at chaos and chance, 3I Atlas began whispering something different, something deliberate. From its shockingly stable trajectory, to its baffling anti-tail, to the slow, almost mathematical evolution of its core structure, this object hasn't behaved like anything we've catalogued. And now, with China's deep space imaging revealing what may be engineered symmetry beneath its icy surface, we're confronted with a question that no telescope can answer. Are we seeing a piece of natural chaos, or a silent probe with a purpose? It's not just speculation anymore. It's not just fringe theorists watching webcam feeds of sky surveys. The data is stacking up. The silence from authorities is louder than ever, and the pace of classified rerouting, blocked telescope feeds, and abruptly cancelled research access, especially in international science partnerships, paints a disturbing picture. We are not being told what 3I Atlas truly is, and maybe that's the point. Because whether or not this object was designed, whether or not it contains intelligence or simply reflects it, the effect is the same. We're not in control of the narrative, something else is, and it's writing the script while we're still figuring out the first line. China's imaging arrays, their lunar-grounded telescopes, infrared satellites, and spectral analysis modules have already picked up what the rest of the world seems hesitant to admit. There are patterns inside, patterns with symmetry, and internal motion that can't be explained by physics alone. Wobble, predictable. But when the wobble starts stabilizing and does so faster than rotational decay allows, something is actively compensating. When the object begins aligning along solar vectors, even when it should be swayed by solar wind, something is controlling orientation. And when jets fire in patterns that mimic communication signals, repeating, accelerating, reversing polarity, it starts to resemble something else entirely. A system, not a comet. And still, no announcement, no press release, no emergency conferences at the United Nations or synchronized statements from global space agencies, just silence. Rehearsed, practiced, global silence. Which begs a deeper question. If the silence is coordinated, what else is being coordinated? Have negotiations already begun behind doors we'll never see? Are defense agencies running simulations not for impact events, but for interaction? Or has a consensus quietly been reached among the world's scientific elite that the public for now should be left in the dark, because darkness is easier to control than panic, and yet something has changed? Even amateur astronomers, whose independent lenses have no filters, no security clearances, are reporting the same anomalies, the same jet symmetry, the same light phase shifts, the same feeling that something's off, but they lack one thing, the authority to define it. That responsibility, that privilege, still rests in the hands of those with the deepest telescopes and the quietest rooms. And those hands are not moving. They're watching, measuring, whispering in frequencies we're not invited to hear. Maybe because what they're seeing isn't just strange. Maybe it's ancient. Maybe it's designed to be noticed at exactly this point in history. not when we first looked at the stars, and not when we colonized the moon, but now, when our planet is wired, networked, and alert. When we can share information in real time, and yet still choose silence when the data becomes too loud. Because the truth about 3i Atlas might be simple and terrifying. It was always meant to be seen, not discovered early, not decoded by accident, but witnessed, up close, in full spectral resolution, at this exact point in time. And maybe that's why its trajectory hasn't deviated, why it's remained eerily stable, why it continues to perform maneuvers that look less like deflections and more like intentions. You don't reveal yourself all at once if you're intelligent. You introduce tension, patterns, questions. You test the observer. And right now, Earth is the observer. The real question is, are we passing the test? Or are we simply reacting the way intelligent life always does when it stares into a mirror for the first time? Not with understanding, but with denial. NASA isn't speaking, China isn't elaborating, and the rest of the world's research community, normally quick to speculate, has gone uncharacteristically cold. Because the game has changed. This isn't about comets anymore, it's about contact. And contact doesn't always come with a voice or a face. Sometimes it comes in the form of a cold, mathematically perfect object. One that chooses silence, one that orbits not just a star, but an idea, a purpose, a timeline. One that waits until we stop looking at its surface and begin asking the real question. What is it waiting for? Because if this thing has intelligence, it also has intent. And if it has intent, then everything we've seen so far, every jet, every signal, every silence, is not the anomaly, it's the introduction.